Hello, everyone. We haven't streamed in about a little over a week. Been a little busy. But today we're streaming. Give me 1 second to get my stream chat up. Today's focus is trying to learn particle physics. So I'm going to start a new, I'm going to start a new project. I'm going to practice particle physics. The goal is to make a firework. That's going to include a particle class and a firework class. So chat. The stream. Pop that bad boy up top. That's perfect. Yeah, I like that. Okay, creating a new project. Visual Studio. Get my laptop. So I've already kind of dipped my toes into particle physics using ChatGPT, and so this one I'm not going to use any ChatGPT unless it's to teach me, teach me something. But ChatGPT is not going to write any code for me. So this project I have, it's a perfectly working fire. I just need to get it on GitHub. Is my microphone even on? Pretty sure it is. The microphone is on. Get that new project going. Empty project. Firework. Pushed. Up. That needs to close. There we go. Probably should have set this up. I wanted to force myself to commit project. Perfect. All right. Get our project set up. So if you've never worked with Raylib, I'm gonna set up a Raylib. So for a Raylib project, right, first, you're going to create your main. You're going to return 0. Next, you're going to create a while loop. So while window should close, and you're going to include the exclamation mark, so while window shouldn't close, basically. And then you're going to create constant ints for screen width, screen height. You're going to apply what you want. I usually work in 1280 by 720. Next up, you're going to initialize the window, init window, and apply screen width, screen height to it. And then you're going to apply a name to it, and it's going to be firework for this project. Next up, we're going to set the target FPS. It's going to be 60 frames per second. Then you're going to get in your while loop. Want to begin. Right. Init. No, hold on. Yes, begin drawing is first. Okay, begin drawing. Then you're going to clear background, and we're going to apply gray white to that. We're going to allow some space above begin drawing because that's where we are going to draw our logic code. And we're going to type end drawing afterwards, and all of our graphic rendering goes here, right? So if you wanted to spawn a circle into the world, draw circle. And then close window, going to be outside of your while loop right before you return 0. So let's go back to drawing that circle. We're going to take probably size and a radius, a center Y, float, radius, color. Okay, center X, call it 100, then 100, where we're positioning it in the world. And the radius is basically the size. Let's make it a 50. And then we're going to add a color. We'll color this one red. Then we spawn it. Give me a second to where my Streamlab is set up. Yes, it's. We got a red circle. But if we draw that circle outside, then we no longer have. What the fuck? I was wrong there. I might be missing something. Every time I've tried to draw something outside of that begin drawing and clear background. Anyways, I was wrong. Okay, so we're gonna make a particle class. In our particle class, we're gonna include Raylib, include IOStream, random. Okay, we're going to create public variables. We're going to create private variables. Okay, so then we're going to create a constructor for the particle class. We're going to take in the constructor as well. We need a position. We need velocity. The lifespan. And the color. Also the size of the particle. A method to update, method to draw. So update the position in the world and then draw the particle. I'm gonna grab some water. So when we construct the particles, we're going to put the position, life, velocity, float life, span, and color. Spell ever. Good there. Okay. Let's cool. I guess it should be. flow life color and position is position. And is and what do we run when we... Oh, hey, what's up, Luke? Rough Senpai 2 guy who has a YouTube channel. I thought for a moment it was you. An identical for me. I'm gonna look him up. Is he streaming right now? Welcome to the stream. How's your projects going? Come on, this guy's like way cuter than me. What kind of content does he make? I don't watch much anime. Okay. Deconstructor. Oh, we don't add anything in the deconstructor. We're gonna take delta time. What do we call it? We finished, but you got too tired of Pi game. Yeah. I can relate to that. One of the big reasons why I switched to C++. It's I moved into Godot afterwards to C++. Have you tried Godot at all? If you know Python, you're gonna be able to pick up Godot very, very easy. Time. Okay. Using delta time, position X and just gonna change the position in the world. And then lifespan. Delta. Hmm. 60. I'm studying C++. And to return to Python later on. I want to have a strong base in C, C++. Okay. What's the resources that you're using to learn C++? Taking an It is important that we static cast. I'm just curious what color. It's the alpha value. 0 means fully transparent, 250 means solid. Okay, does that make sense? The lifespan, which gets, I think it's called decremented, technical. Yes, the decrement operation. Wait, know my terms. Okay, now we just need to draw the particle. Draw. Now this code here, it kind of confuses me because I feel like with the position, the particle size, color, because the logic that I'm reading behind this code here is that we're never actually deleting the circles, we're just making them invisible. Oh, I'm wondering how I'm supposed to delete the particle. It would be here. But maybe not, because if lifespan is 0, you know, I could test in the code just by out later though. Okay, so a lot of the firework code I don't understand. Okay, we need vector. Need particle. Boom. Boom, boom. Yeah. Explains every minor detail too. Reading about unreferenced parameters is thought about it in unreferenced parameters. You definitely get a lot more detail through C++. Like memory management is something that I never really thought about. And looking back to when I was coding in Python, I had made a game that the controls were just very, very clunky. And I'm wondering if that was because Python is slow because it uses trash collection, or if it was like a Pygame thing. Yeah, unreferenced parameters are a function parameter that or function parameters that are declared but never used within the function body. That can happen for various reasons, as Getting the parameter name. I never thought about static casting the void parameter. Well, that does make sense though, because yeah, there's been a time where I have needed to do something like that. It actually kind of gives me an idea of something that I could work with on a project that I made recently. I think it's good that you're learning C++, because like by learning C++, you're also learning a lot of what goes on under the hood. Oh, you're using learn CPP. Okay. Point 4. Instruction of function parameters and argument. How do you like learncpp.com? I haven't touched it at all. I've been I use a Udemy class to learn the basics. Jeez, I can't type. Ooh. Having the hardest time. We have colors. And then we're gonna create the firework near the Oh, you got it from Tokyo Spliff streams. I don't know, but it gave me a better understanding on function than... Okay. I might check it out. I'm at a point right now with my developing where I'm gaining a lot of I'm gaining a lot of skill from just making random projects. But I'm missing what I'm missing right now is that I have nothing that I'm like learning from. Minus a particle physics book, but I'm learning how physics systems work in games. I'm actually learning code. I need something right now that I could learn actual code from. I think you're gonna get a much better understanding of classes and object-oriented programming as well compared to learning in Python. I think Python's kind of weird for it. But C++ to me just makes more sense as far as object-oriented programming goes. So we need to update the firework and draw the fire. We need a bool if it's exploded. We're gonna take a vector of particles. Okay, that just answered my question earlier, whether or not we are deleting the particles as they go away. We are doing it here because we're using a pointer of particles that later we're going to delete in the code. Firework. Firework. Boom. And we need to that. We're going to initialize the firework when we create the class. And this, we're going to delete a for loop for particle be in particles. Delete the particle. Okay, there's our memory management. How's the update been for, like the progress been for Tokyo Spliff? I have not watched his streams in about a month. Since he added the shark in, I haven't really watched. Buzz firework. And then firework update. And then fade. That's all. Yes. I think it's too basic for you, but it explains the basic. Very little detail. Might be good for a reinforcement. I don't know. For what I've seen, it only covers the basics. What's up, Audio Tour? How have you been? Welcome back to the stream. So, I believe, Luke, I believe in always, no matter how good you are at something, going over the fundamentals and strengthening fundamentals. So I have no problem going back and reinforcing stuff I've already learned. There may be little details that I never really picked up my first way around or my second way around. I've been great. School started this week, so it's been interesting. I'm taking a really basic class for HTML, and I already know a little bit of HTML, like more than the whole of the class knows. So the professor is willing to like challenge me to do something a little less basic than what they're doing. But no details as of yet what I would be doing. How about you? Any updates for you? Alright. He did one yesterday. I don't understand that much of what he does in the streams, but he was just chilling, tweaking logic things. I did see that. I popped in for 5 minutes at most, and then I had to go to work. You know, I felt the same too when I first started watching him. Like, I had no understanding. Now, dude, like 6 months later, it's kind of weird because now I'm like kind of understanding some of what he's doing. Been working on a processor lately. What processing what? I mean, Tokyo Spliff's his his project is like so freaking advanced and huge that I feel like I'm never really gonna actually fully understand everything, you know? But I'm starting to recognize like, oh, this is a function, or he's probably calling that somewhere else. Or oh, he's taking like something that he's doing for rendering and he's applying more things to what he's that initial thing he's rendering. Alright, so this initializing firework code is where I am lost because it includes a lot of concepts that I fully grasped yet. Specifically about pointer. It's a cluster of Raspberry Pis that emulate a virtual machine that's used for machine learning on different units. Jesus fucking Christ, that is well above my ability. um, I um, I bought a Raspberry Pi chip, like a while ago, about 6 months ago, and it's all it's really like turned into was a streaming thing. Like I'll take it to people's houses and then get it connected to the internet, and it's got like Netflix. Some roommates appeared to some girls, but there's a bunch of spammers. I don't know if it's bots or real people annoying anyway. On his stream, on Tokyo Spliff's stream. I've always wondered what his roommates looked like. That dude's I I kind of the word. So he's okay. He was talking about that too. It says he's been programmed for 8 years, but the time doesn't really matter because in the first 5 he didn't know what he was doing. Yada yada yada. I'm a moderator over there on my other account, Leaper. Tons of spammers on Tokyo. But okay, back to what I was saying is he's got roommates. He's got the ability to get like the skill to get a really nice programming job, like a nice cushy, well-paying programming job. But instead, he I mean I'm pretty sure he has a job because I think he said something about working doing ragdoll physics. I think, but he's working to pay the bills to fund his real dream project. And he's not going and getting that cushy job where he can afford a house, save money, do all that, like the safe route. He's going for his dream. And he works fucking hard. I respect the hell out of that. For so I'm assuming, yeah, we're iterating through all the max particles. Won't disclose. No, no. Yeah, please don't dox anybody here. He talks about getting focused too. His streams started as 5 hour long stuff and now it's 8 to 12. I wish I had the capacity right now for that. Um and the logic. I think that's something you have to work up to be able to have that brain capacity. And I get worried about 4 hours usually. Yeah, my brain just gets toast after 4 hours. But I think that's a skill that you have to train to be able to sit there for 8 to 12 hours a day. And be able to still think correctly at that and apply your thinking to your programs. That's something I would want to work up to. I I had this idea where I wanted to do like a 24-hour stream, and I don't know if I want to talk about that because it's gonna happen. I'm not the type that likes to talk about things. I like to do the things, and then after I have done the things and I have something to show for it, that's when I like to talk about it. I mean, the time doesn't matter too much, but honestly, the more time you spend, the more stuff gets done. I care about it to some extent. Does also drink. Yeah, I drink a lot of caffeine as well. Got some right here. All right. So we have the angle of the particle. Static casting that to a float. I get random value. Pretty sure that's a Raylib function. Yes, it's a Raylib function. Oh, it's got random seed values too. That's cool. Get a seed for the random number gen. If you have a goal, coding becomes addicting, it seems. It does. It really does. I think I found my goal. I'm doing I've been doing a lot of focus on not particle, game physics specifically. And I've been like hyper focused on getting better at game physics. That's what this project's for. Um How do we use that? And why is it probably to keep the randomness? Frustrated with a problem, or for whatever reason that worms me out quick. I gotta take a break. Breaks are good. Um, yeah, I think like getting away from the computer and getting back to a problem. I think your brain subconsciously thinks about that problem without you even being aware of it. And that after you take your break and come back to it, you like come back refreshed. You actually have more brain capacity, and you may subconsciously even have the answer to that problem. Okay, get random value. This is angle, so be. Why this though? I'm gonna run to the restroom real quick. Be right back. All right, we're back. Sometimes that problem will come up in a dream of mine. You know, I have video game ideas in my dreams sometimes, and then I'll write them down. Like, I'll wake up and I'll write them down. And then I'll go back to sleep, I'll wake up, I'll look at it, and I'm like, that is the stupidest idea for a video game ever. Oh, degrees to radians. That makes sense. Converting the degree that we get from here to a... Then we're going to apply that radian somewhere later. Math for 2? If we're using degrees and radians, we're gonna need like sin and... Okay, then the speed. Being a random value. 1,000, 40,000. Boot. Float. Why are we dividing it by a... Just leave that step out. Leave that step out and then just remove 2 zeros. I don't know why I did that originally. Okay. Yes, this is where we... Cosine of the angle times speed. What are you doing though? What's the point of this line? Calculates the horizontal component, calculates the vertical component. Assume the angle is in radians. Multiply by speed, a 2D vector. Makes sense. Okay. So it's applying angle to speed for the x, coordinate of the vector. Same thing for the y. Yeah. Up. Color. I just need a random color. Then what's the term for this? Index. Get a random index. Yeah. And then we're going to push it back to particle. Particle. Oh, we forgot. Okay, there we go. All right. So projects end up never being finished. Oh. I do also sometimes struggle with losing the honeymoon phase of a project idea, so projects end up never getting finished. I can relate. So two of the biggest reasons why my projects end is because I get bored of the project, or because the code just gets so tangled and messy, and I don't want to go in and rearrange it and fix it. A lot of the issues would be like if two classes are interacting with each other and also interacting with main, like variables that are inside of main, that tends to like really screw me up. Um, and I very, very rarely go back to an old project, but they are always there if I ever want to. Okay, for auto dereference particle particle update. This is where we need delta time. I mean, correct, right? We're calling update particle delta time. We don't have to create a different delta time outside. Okay, this line here I'm a little. Yeah, look at the old horrible code and see how much you've grown too. Definitely, I think it's important to do that too. I remember my old like if else like little question coding things like what is the answer to this? If answer equals blank, else if answer equals blank, else if answer equals blank, else blank. And then just repetition throughout the whole thing. Um, Whereas today, you know, you just pop a little function that takes an input, drops an output, and then a little for loop for an array of questions and answers. Simple. Okay. Container and purpose. This is a standard vector particle pointer. Vector of pointer particle. Holding pointers to particle objects. Goal is to remove all particle pointers where is alive returns false. There are particles that are no longer alive. This is the code, finally, where we delete. But aren't we also deleting? No, because we're dereferencing. Yeah, when it dereferences, it deletes a memory. But here is where we call that dereference. Okay, particles that begin is iterator to the next start of the vector. And then end iterator to the end of the vector. Return if it isn't alive. Lambda function. I've not used those ever. It returns true if the particle is not alive. This defines an unwanted condition. It returns an iterator pointing to the new vector after. That denotes function. Single particle pointer as input. And returns P is not. Yeah, tons of prints. This is a live method of the particle object. Not alive. The function returns true, making it marking a firm. This live returns false. And erasing. Remove if only rearranges the vector, does not shrink its size to actually remove the unwanted elements we call erase. Okay. So let's write this code. See if we understand it. So first we're going through all the particles. Then we're updating their position in the world. Particle dot erase. So remove if rearranges the vector, but doesn't remove any of the elements of the vector size of the vector. And this is the lambda function. Return E not alive. Return if it's not alive. Needs to be a cat. Good. Oh, we never made it. So if lifespan equals 0, we're going to return true. Greater than 0. That's X. Dot erase. Single element erase. Then we throw the iterator in. It only takes one. All this code here is to figure out whether it needs to be erased or not. So remove if. Rearranges a vector so that the unwanted element for which the condition is true are moved to the end of the vector. So this is finding that unwanted element. What? The goal is to remove all pointers to particle objects in the standard vector particle of particles where particle returns is alive being false. The code uses two main functions, remove if and dot erase. Okay. So breaking it into parts. A condition. Remove if, begin, end condition. Or the algorithm library. What it does, it iterates over the range, begin, end, for each element in the range. Oh, okay. Okay. So here is starting from the beginning of the vector, then it goes to the end of the vector, iterating through each element of that vector, looking for this. For each element P in the range, it applies a condition. So if this lambda function here returns is not alive, true? Hold on. Yeah. If the condition, okay, so the condition is returning if it's not alive. So if this returns not alive, then it marks the element to be removed. And then moves it to the end of the vector. I'm assuming right here. Yeah, so it moves it to the end of the vector. Such that all the to be removed elements are moved to the end of the vector. So we're iterating through. It finds one on the 22nd, moves it to the left, finishes iterating, then returns back to iterate because it's in a loop. Yeah, because it's in the main while loop, so it's constantly running. Iterates, finds another, moves it to the end. It's got to delete somewhere. Should be erased right here, right? So what is this? Okay. Rearranges a vector that all the to be removed elements are moved to the end of the vector. That I have highlighted should be what moves it to the end, but then the erase. This is an inline function. This is a lambda function that takes a pointer to a particle and returns true if the particle is not alive. Okay, that makes sense. And then erase start end. Oh, okay. This whole line of code is the start. And this is the end. So erase particles.erase. Actually remove the elements from the vector, resizing it. Start. The iterator returned by standard remove if, pointing to the first to be removed particle. End, the current end of the vector. Removes all elements in the range, start end. Adjust the size of the vector, effectively discarding the removed elements. Okay. Check each element. Okay. Check each element with the condition is alive. So from the beginning of the vector to the end of the vector, we're checking each element that this returns true. And then it's rearranging and moving anything to the end. Where does it do that though? Here. Maybe? Okay, I think I get it. Okay, we're iterating through from the beginning to the end. If anything returns true, we're moving it to the end. And then this whole function here is going to return a number. Let's say there was 10 particles flagged for being removed. It's going to return 90, the number 90. And then we have dot erase here that erases from 90 to the end of the vector. And now we have, for the next call of this line, it's from 1 to 90, rather than the original was 1 to 100. I think I get this. I think that's it. That's it's confusing. It's a one line, like at my current skill level, this would take multiple lines of code for me to make. But this condenses it all into one. Like I forgot the exact name of it, but there's a way you can write an if statement on code. Ooh, that was a brain experiment right there. Now that's done. We just need to create a reference loop, reference auto particle, change base loop. Darwa drop. Okay. Classes are done. Now in the main loop. We're gonna use left mouse button on the fireworks. Button print equal position. return the X and Y coordinates of the mouse. We're going to use that to vector for the fireworks. We can spawn multiple fireworks. Spawn the we're pushing back since the pointer we need to use new and delete. Spawn position. Okay, so we're adding that elements to the vector, but where do we delete the elements after? So reference firework in the fireworks vector. Update. Oh, delta time. Graphics rendering for auto reference firework and fireworks. And Darwa. Here's where we delete. Okay. Not. We're closed. For the same dereference, firework and fireworks. Delete. Firework. Okay. Okay, memory management system. Back new firework every time we click. Deleting it off the memory. Then for firework and fireworks, update code that we created, the draw for rendering, and then we have one last that same thing that we just spent like 15 minutes trying to understand. Move if function yeah, if I remember. Erase. So I'm going to remove the element. We're iterating through fireworks from the beginning to the end. This returns true. We are moving that element to the end of the vector. And then we're returning a number. And then we iterate from that number to the end of the fireworks vector. We're erasing that firework. That's it. Now we should be able to spawn fireworks on the map wherever we want, just like that. Oh, yeah. I don't like the speed. We're not applying enough. We're not applying enough gravity. Where we did that. Division by 100. Best. Maybe we do need that division. Yeah, same thing. Applying gravity at all. You know, there's not really much gravity in fireworks to begin with. There are fireworks that have gravity. Main value for gravity to begin. That's not it. Okay, let's see how that works. Keeps it. Super insane gravity value. We may just be applying. No, it's applying it to it. Whoa. You know, I was just thinking, that looks like a shotgun. And that is like, this is a system that could work really well for like a side-scrolling shotgun game. Not incrementing correct. I'm just doing the wrong logic. I delta. The only other method I think I can fix this with is maybe an initial velocity and then make this velocity initial velocity, and then afterwards velocity. No, I don't think that really matters. I think that would just literally do the same thing. No longer applying. Delta time. Yeah, see if we apply this to x, velocity x, and then the color being black, we've got a fucking shotgun. Boom. It's so cool. And if we got rid of angle, concept. We accomplished our project of creating a firework. So one of the next projects I want to work on with particle physics is fire. I want to make realistic looking fire. I want it to follow the mouse as well. I'm gonna use the restroom. I'll be right back. Enjoy some fireworks while I'm gone. Ooh, all right, we're back. I think we should increase the speed a little bit. I like that too, because they have different... Wait, hold on. I don't know if you can see, but some of them will they'll lose their they will lose their solidness and become transparent, and then they'll blink back into solid and then go back to being transparent. I wonder why that is. On the bottom right, you can see it. It's blinking in and out of transparency. Our transparency value is under particle, this right here. Lifespan. Make the particles a tiny bit bigger, as you can see. We should spawn less particles too. Size, and then oh, it's probably because he colliding with some type of logic for here, maybe. Lifetime is random value. Here. About 25 for now. So it's hard to see when everything's moving fast, but this is going to cause issues later when I do like the fire of it disappearing, reappearing. Something I'll have to figure out. Write a note. It's actually kind of fun to watch this. I'm not going to do any more programming for today. I have to head to work. It snowed too, so I've got to leave a little early. But I super accomplished my goal for today. And I learned a new line of code that is honestly going to be like useful in probably every single project potentially that I will be using or making going forward, as long as I'm like continuing with the particle physics. Or even if I just have to like iterate through a vector and delete elements that are delete elements that I need to delete. Completed a project. This is going to be a part of a video, but not the main. Next project is going to be, we'll figure it out. For now, though, I'm going to go ahead and get ready for work. Thank you guys for watching. I appreciate you coming in. And hope you all enjoy.